In this video, we're going to look at basic visualization, and we're also going to look at a package that's called ggplot, which will allow us to make more advanced plots. So in this lecture, you'll see that I've got the lecture script open here. So as a reminder, once you download the lecture script from Canvas, if you're following along, you can open that either by clicking on File and going to Open File, or down here you can click on the Files tab, click this button, navigate to the folder that contains the script, and then open that and click on the script here. Alright, so what we're going to start out with is we're going to open a data set that contains information from different items from Starbucks. And so you'll want to download that data set from Canvas. It's located in the starbucks.csv file. And remember from last time, whenever we're working with a data set, it's a really good idea to set your working directory. And so what your working directory is that is a place on your computer where you're going to store your files for a particular project. And so it doesn't always have to be the same folder on your computer that you're working with. You might have different folders for different projects, but this way it tells R, at least for right now, everything that I need is going to be in this particular place. Now I have the code here, and you'll remember once we generate the code for the working directory, it's always a good idea to go ahead and copy that code and place it in your script. So to start with, let's remind ourselves of how we can actually use RStudio to help us generate this code. So I'm going to come down here and make sure that I have the Files tab open. And then I'm going to click these three dots. And then what I'm going to do is navigate to the place on my computer where I have the data set located. Right, and remember as we navigate through here, it's not going to show you any of the files. It's only going to show you the folders. So I'm going to click open. Notice I've got the Starbucks data set right here, or the file containing that data set. And then what I'm going to do is click on this little gear. I'm going to set as working directory, and you'll see that it auto-generates the code down here. So I'm just going to copy that, paste it up here. And the reason I want to do this is most of the time when you're working with a data set, you're not just going to write a script once and never visit that script again. You're probably going to load this data set several times. You're going to be working over this over several different days. And so now when I revisit this script, all I have to do is run this line of code. I don't have to go through those steps again. All right, so I'm going to read in the data set. I'm going to name the data set Starbucks. I'm going to use the read.table function. You'll notice that I have the name of the data set in quotations. This is a .csv file. Now, since I'm using the read.table function, I have to specify what is used to separate the text in the document. And so what CSV stands for is comma separated values. And so essentially this is a text file where the different entries are separated by a comma. And so that's why when reading in a .csv file using the read.table, I'm going to specify sep, which stands for separation, using a comma. And then also we have the header equals true, and then we don't have to worry about the quote for right now. So running this. Now, once we read in a data set, we want to make sure that we always do, just a couple quick checks on that data set to make sure that everything looks good. So one thing that we can do is we can use the head function. So if we run this, notice down here what it's going to do is read in the first 6 rows of the data set. And so for this particular data set, we can see this data set contains name, calories, fat, carb, fiber, and there's not enough room horizontally, so then it jumps down to the next line, and we've got protein as well. Now you can also read about this data set by following the link that I have here in the notes. And if you read that data set, you'll get more information about each of these columns. Some other things that we can do is we could use the names function. And so remember, the names function will give us the names for the columns. We could also come over here in the environment window, and if we click on the data here, it will open it in a separate window and we get the full data set. Now this data set has 113 rows and it only has 6 columns, so it's fairly small. And so opening it this way to kind of scan through and check is always a good idea. Now other data sets, if you have very, very large data sets, clicking on the data here and then opening it, this window can run pretty slow. And so that's why this isn't necessarily always the best way to check a data set, especially if that data set is really large. But for the Starbucks data set, it's perfectly fine. Now, one thing that I always like to do if I do have a data set that's small enough that I can look at it this way is I like to scroll through, see if I see any missing values, anything that looks unusual. And looking through here, I really don't see anything, and so I'm not too concerned. Now later in the course, we are going to spend a whole week looking at missing data. There's some really nice packages that can help you if you have missing data in your data set and to see how to visualize where that missingness is coming from. But again, we'll look at that in the future. All right. So now that we've got our data set read in, we're going to start by looking at some examples of just some basic plots. And so the first plot that we're going to look at is a box plot of calories, and we're going to look at how to change the main title. Now when we say main title, I mean the one that goes at the very top of the plot. Now if it's been a while since you've seen a box plot, I do have a website here for you to visit to read about box plots. But as a reminder, box plots are really useful when we have quantitative data. And what they do for us is they give us a way to visualize the spread of the data, because what the box plot is going to look at is in the center, it's going to have the median, it's going to have the quantiles on either side of the median, and then it's going to go all the way out to the minimum and maximum of the data set. And if there are any outliers, then those outliers will be shown with points on either end of that box plot. Now, how those outliers are determined, most of the time that is 1.5 times what's called the IQR, plus or minus the second and third or second and fourth quantiles. But make sure I got that right in my head there. But there are other ways to determine that, so I'm not going to spend too much time here talking about those outliers. But let's run this line of code, and we can look at our box plot here. Now, one thing to notice, you can see that I can move this window to make this easier to see. And so here's our main title. You'll notice that we've got our box plot here. And then again, just as a reminder, so here we have the median. Here we have the first and the third quantile. And so essentially what that means is at the median, 50% of the data falls below and above the median. At the first quantile, 25% of the data falls below the first quantile, 75% of the data falls above. And for the third quantile, you have 25% of the data above and 75% of the data below. Now just a second ago when I was talking about how to identify outliers, I realized that I misspoke when I said 1.5 times the IQR plus or minus. I should have said plus or minus the first and the third quantile is what I should have said there. And then the IQR, what it is it's a measure of spread. And again, that website that I've got linked there, if all of that sounds completely, you think, oh my goodness, I don't even know what you're talking about, that's perfectly fine. Just go and have a look at that website to review box plots, and it's got those different pieces there. And then you'll notice here along the axis we have calories. Now looking here, what we can see is for the calories variable, our median falls at about 350 calories. We've got a minimum, probably about 80 calories, and a maximum, probably around 650 based on this plot. Now going back to the code, how we create this is, again, we're using the box plot function. The first argument that we're going to give in the box plot function is the data or the variable that we want to create that box plot of. So just to see the different arguments for the box plot function, down here in the console I'm going to do question mark box plot. And we'll see here in the help, we have the different arguments that can be placed inside of the box plot function. Changing main is how we change the title. And so we're going to call this calories and Starbucks food items. Now, one thing that I think is always a really good idea to put in any of the titles for a plot that you make, I think the sample size is always important to include, because you'll notice looking at this box plot, it's not immediately apparent how many actual data points went into making this plot. And so if you'll remember from our data set, we saw that there were 113 rows. We could have also come over here to see there were 113 observations. So into my title, I'm going to add in n equals 113. Again, I just think that's good practice when creating plots to always remind ourselves how many observations went into making that plot. And the last thing is I need to label my axes for my plot. So the axes that fall here are called the y-axis, and the axis down below is the x-axis. Now for a box plot, we only need to label one of the axes, and so because of the orientation of this box plot, we're going to label the y-axis. And so I'm going to use the argument ylab, and then in quotations, I'm going to say what I want that axis to be labeled, and so I want it to be labeled calories. Now, if we go back to our help function, you'll notice that one of the arguments is horizontal equals false. So by default, we're going to have a box plot that is vertical, but we could also add in comma. Now notice when I go to do this, I'm going to keep on typing. It's pretty much going to go off the screen. So one thing you can do is you can always click enter. And we're going to set horizontal equals to true. And so this way my code isn't going to run all the way off the page, and you can really do this for any of the arguments in a function. You just want to make sure the line ends with a comma. Now let's try running this. And you're going to notice that I get an error, and it says figure margins are too large. If you ever see this error, what it means is the window where you're trying to make the plot is just too small. So if we make it larger, and then we can run this code again, notice the plot appears just fine. And by placing in that horizontal equals true, notice that our box plot is now horizontal, and we have that new information added in the title. Now these are just a few of the things that we can change with a plot. We're going to see that there are lots and lots of different options. All right, so next we're going to create a histogram, and this time we're going to create a histogram of the fiber variable. I'm going to create a histogram using the HIST function. So again, I want to make sure my window is big enough. And here is my histogram. Notice we've changed the title. This time I want to label both my X and my Y axis. So I've labeled, oh sorry, not my Y, X and Y, just my X axis. I want to label it fiber, so that's why you have X lab here as fiber, and then again the main is equal to fiber and Starbucks food items. And I could add in the n equals 113 here, just for good practice. Now another thing that you might say is, okay, well that's really nice, we've created this plot, but this plot exists in RStudio. How can I now take this plot and place it somewhere where I could use it? Well, here in the plotting window, if you have export, you can either click a save as image or save as a PDF, and that's how you can save this file to export into a document that you're writing. The other thing is notice if we look here along the x-axis of this histogram, if I move it inward, notice it gets really squished and it doesn't look as good. If you were to try to export when it looks like this, it's going to export the image just like this. So usually what I try to do is I do try to go ahead and expand out this window to make the plot how I want it to look, even if that means my code gets squished over here. Export it, save the image as I need it, and then I can keep on writing my code by moving my window around. Alright, one last plot we're going to look at is a scatter plot. So as a reminder, a scatter plot is useful when we're making a comparison between two quantitative variables. To make a scatter plot, we use the plot function. And I'm going to plot my two variables that I want to compare. So maybe I want to compare fat and protein for the different items in the Starbucks data set. Notice that I list the fat variable first and the protein variable second. Whichever variable you list first is going to be along the x-axis, and whichever variable you list second will be along the y-axis. Here I'm labeling the x-axis fat, the y-axis protein. Now this PCH equals 20, that's a new one. So what this stands for is point character. So notice on the plot we have different points for the scatter plot. PCH equals 20 will produce these filled in circles. We could change this to be something else. And you'll notice it changes the points. PCH equals 20 is usually the one that I use. I think it looks the nicest. But again, there are lots and lots of different point types. And then finally, I've changed the title of the plot. And so if we look here, we can see that if we're making a comparison between fat and protein, it does appear the points move slightly up and to the right. So I would probably say there's a weak positive association between these two variables. And again, you can read more about scatter plots here. Alright, so there are lots and lots of different options when it comes to plotting. We've looked at just a couple of those options so far, so let's look at some other ones. So the first thing we're going to do is we're going to read in yet another data set. This is one of the pre-built data sets in R. It is the orange data set. So we're going to call it forward using the data function. Notice here in the environment it says orange promise. This just means it's waiting for me to actually use the data set and then it will populate it here. One way I can use that data set is just by reading about it. So I'm going to use the question mark orange. Oh, sorry, it won't pull it forward yet, but I can go ahead and read about it. And so you'll notice here we've got growth of orange trees. We can see the different variables. So we've got tree, age, circumference, and essentially what this is doing is it's looking at the growth of different trees over time. I could look at the first 7 rows of the data set. And so here we have those first 7 rows. Now notice this is just another way that we could do something very similar to the head function. The head function only gives us the first 6 rows, whereas I specified the first 7 rows, but again, very similar output. So we can see that we have tree, age, and circumference. Again, this is a fairly small data set. It only has 35 observations and 3 variables, so I could click here and open the data set. And so notice what we have here is for tree 1, we have 7 different ages, and at each of those ages we have the circumference of the tree. For tree 2, we have something very similar. We have 7 different ages, or pardon, 7 different ages, and then for each of those ages a circumference reading. If we scroll down, we've got 5 trees total. So essentially what we're doing is we're measuring the circumference of 5 different trees at 7 different ages. So let's start out by making a scatter plot that looks at age versus circumference of the orange trees. So here is that scatter plot, and we can see that as trees get older, they tend to get bigger, and that makes sense. But notice that one of the pieces of information that we're missing here is that really we have 5 different trees. And we can see that for each of the different ages, we have 5 different dots representing the different trees. So it would be more informative if we could include something else to help us distinguish the different trees from one another. Typically in a scatter plot, this is done by either designating a color to each of the trees, or you could also do a different point type. And so instead of all the points being the filled in circles, maybe some of them can be squares and some of them can be triangles and so on. So here, to make a better plot, we'll first run this. And so notice now we've added a color for each of the different trees. So looking at the plot here, notice again we've called age first because it's on the x-axis, circumference because it's on the y. We've specified the point type, which is the shape of the points, to be 20. We've labeled the x and the y-axis. We've also called the main title here, but the piece that we've added in is the COL argument. COL stands for color. And by setting COL equal to orange tree, remember that orange tree took the values 1 through 5. So what this is going to do is it's going to pull 5 different colors. And the way that R stores colors, it stores them 2 different ways. It stores them both by name, so we can call colors by name, or the colors also have a number assigned to them as well. So if we tell it, I want it to be colors 1 through 5, it's going to pull the colors that are associated with the numbers 1 through 5. Now this plot looks much nicer, but we don't know which color is assigned to which tree. So what we can do next is we can add in a legend. So this code right here that I have highlighted, all of this is to make the legend. So I'm going to run this first. And you'll notice where I created the plot when it was smaller and I expanded it, it doesn't look great. So sometimes you just need to rerun it after you make it big. But if you just rerun the legend, it's just going to repopulate the legend. So if you ever run into this issue where your plots are they're kind of looking kind of crazy, what you can do is you can clear all your plots. I'm going to say yes. Now that's going to clear all the plots I've made, but that's perfectly fine. We can rerun our plot, and now we can rerun our legend. And this looks much better. So what we can see here is we've got a color for each of the 5 trees. And so everywhere I see the dark blue dot, that represents tree 2. Every time I see a red dot, that represents tree 1, and so on. Now, whenever you add a legend into a plot, you always want to double check your legend by comparing to your data set. All kinds of things can go wrong. And so we never want to blindly trust what R creates. We always want to make sure we're double checking any output that we can, just doing some checks here and there to make sure that things look like they should. So to start out, what I'm going to do is I'm going to check on tree number 4. And so tree number 4 here is represented by the light blue. And I'm going to see if these light blue values match what I have in the data set. So first, I'm going to call the orange data set. And then you'll notice here in the brackets, remember that anything before the column is rows and anything after is columns. So I'm going to call all of the rows where tree is equal to 4. In other words, I'm pulling all the information for tree 4. So let's spot check some of these points. Now down here, it's kind of hard to distinguish the points from one another, but as we go upward, it's a lot easier to distinguish. So let's check some of these upper ones. So notice for the largest age, we can see that tree 4, again using the light blue, should be somewhere up around 200 or up above 200. And we see that for the largest age, we do have a circumference above 200. What about for the third age? We should have a circumference above 100. So if we go to the third age, we see a circumference above 100. So these are matching. Now the other thing that we could do is we might want to order our points by age and then by circumference. So here I'm calling the orange data set, and again I've got my comma, so anything before is going to represent rows, anything after is going to represent commas. And what I want to do is I want to order all of the rows first by age and then by circumference. So here are all of those. And so we can see at the youngest age, the order of the points from top to bottom should be 1, 3, 5, 4, and 2. Now again, looking at the plot, at the youngest age, it's kind of hard to distinguish the points. So let's skip down to the oldest age, which is here. And we see that at the oldest age point, the smallest circumference is tree 3 and the largest is tree 4. So what this tells me is if I look at my ordering of my points here, it should be tree 3, 1, 5, 4, 5, 2, then 4. So let's see if that matches. Is tree 3 the black dot? And tree 3 is. Is tree 1 the red dot? It is. The green dot is tree 5. The dark blue dot is tree 2, and the light blue is tree 4. So it looks like our plots and the color of our points in our plot and our legend match, so everything looks good. All right, so I've got an even better plot that we can do, and so let me run all of its code with its legend and talk about what we do here. So here what we've done, instead of having the points, we've created smooth lines for each of the tree. And the reason we might want a smooth tree for this particular data set is we know that age is continuous and circumference is continuous. So by creating these as these smooth lines, we're recognizing that even though we measured, at those discrete time points, that growth was happening in between those points. And so this is an example where it would make sense to have a smooth line between the points. And so if you look up here at the plot, in order to create this, I don't actually call the data in the plotting function. Instead, I call null null. And the reason that we do this is so that we can change the limits on the x and the y axis. And so for example, I'm going to base the x limit on the range of the age data set and the y limit on the range of the circumference. So I've created those. Now I still have my x lab, my y lab, the color, and the main all the same. But now we've created that range, we've created the x limit and the y limit based on the range. So now that those are appropriately set, what we can do is now add in these lines one at a time. And we do this using what's called a for loop. So to see how this works, what I'm going to first do is run this first piece of the code. And notice it creates a blank plot where we don't have anything in it, but we do have the appropriate values on the x-axis and on the y-axis. Now what this loop is going to do is for the numbers 1 to 5, and remember we had 5 different trees, it's going to create a line for each of the trees individually and add them on. Each of the lines are going to be created using the line function, where the line function is going to look at the age for tree I, and then it's going to look at the circumference for tree I, and then it's going to make the color based on the legend colors. All right, so let's see what this would look like outside the loop. So I is going to go from 1 to 5. So let's just set I equal to 1 to start with. So I'm not actually going to run this inside the loop. I'm just going to run this line here. All right, so we've added the first line. The next time that this loop cycles through, I is going to be equal to 2. So I set I equal to 2, and I run this line again, and a new line's added. And then I could set I equal to 3, and then it's going to create the line for the third tree, and so on. So what this for I and 1 to 5 does is instead of me having to manually go 1, 2, and 3, it just runs it for me. And so running it all together, see we get all 5 lines. And then the last thing here is we create the legend. And we can see that x equals top left places the legend in the top left. Now depending on what your plot looks like, you may want to have your legend somewhere else. You could do top right, bottom left, bottom right. It really will, you just want to place it somewhere in your plot that's out of the way of the data visualization. Now for the legend names, these were all created up here earlier when we created the names and the colors. Colors are legend colors. Line type is the type of line. So here we use type 1. If we change this, we could have dotted lines, dashed lines, lots of different pieces. And then the N here, this is specifying no box around the legend. So in the practice exercises, you're going to play with some different legends in these different pieces. So I really suggest here in this video, play around with these different pieces to create these legends, see what the different lines do, and then of course if you have any questions, please let me know. Alright, so we could also combine plots. We could do just using what's called the par function. So what the par function is going to do is it's going to create a grid that we could place different plots in. Now, in order to create that grid, we need to specify what we want the grid to look like, and we use the MF row to do that. So this is saying I want you to create a grid that has 1 row and 3 columns. And now what we're going to do is each of the plots that we create are going to be placed in this grid. So these are plots that we've created in the past. So we created a box plot. Notice it's placed in the first place in the grid. We created a histogram, and we created the scatter plot. And so that's what the par MF row does. Now usually after you do this, you might create something that looks like this, and then you want to revert back to only having 1 plot in your plotting window. Well, to change it back, you just change it back to a grid of 1 and 1. And notice now if we go back and recreate the box plot, it just places it by itself. Alright, so the last thing we're going to look at in the video is ggplot. We're just going to do an introduction to ggplot. We're going to work a lot more with it next week. ggplot is a more complicated plotting or way to make plots, but it's also a lot more flexible. And so again, the package that we're going to use is called ggplot or ggplot2 if we're going to actually call it from R. And what it does is it makes use of what are called factors. So conceptually, a factor is a variable in R that takes on a limited number of different values. Typically, we refer to these as categorical variables. So if you've heard of a categorical variable before, we're essentially talking about factors. But the difference is that factors in R are going to be stored as integer values. And so those integer values match with a corresponding set of character values. And so ggplot2 is one of the core members of what is called the tidyverse. The packages in the tidyverse share a common philosophy of data and R programming, and they're designed to work together naturally. We are going to work a ton with the tidyverse in this class. We're just starting with the ggplot portion of tidyverse. So as always, the very first thing we need to do if we're going to use a package is we need to install and load it. So if you already have the tidyverse installed, you can just use the library function to load it. If you don't already have it installed, as a reminder to install a new package, you can click on Tools, Install Packages, and then you're going to want to look for the tidyverse. So you'll notice that once you load in the tidyverse, there are several packages that are part of the tidyverse. Again, we're going to be working with the ggplot2, but we're going to use all these other packages later on in the class. And then there's always going to be a couple conflicts. Basically what these are saying is that one of the packages you download is the dplyr. We'll work with this later on. It calls in a function called filter, which masks the filter that was previously there. And same thing with the lag function. But for right now, we don't have to worry about that. So we're going to work again with that orange data set that we've already seen. And so there's a little bit more about the orange data set. We've got its structure, there's the head piece of it, and then again we could read about the data set. So we don't actually need to call the library there again. I'm going to delete that out. So let's look at the basics of ggplot. So one way to think of how ggplot creates plots is if you've ever seen transparency sheets. So basically it's a plastic clear sheet that has something on it, and you can layer these sheets to create different visualizations. ggplot works very similarly. The first layer in a plot for when creating ggplot is just going to be an empty graph. And so we can see this by calling ggplot and giving it the data orange. And so notice it really creates an empty graph. There's nothing here. There's no axes, there's no box, there's nothing. It is just an empty space. And you'll notice it does have kind of a gray background. So it really is just an empty space. The next layer we're going to put on there is going to be the plot. And so basic plots have 3 things in ggplot. You first create the empty plot by calling the data set. And then you're going to have a layer with points or lines. And then you're going to have what's called a mapping argument. So let's look at what this looks like. So again, we're going to call the ggplot with the data. We're going to add on a plus sign. So think of this as I'm going to add on a layer here. I'm going to call the function that I want to use. So the function will determine what type of plot it is you're making. So g_on_point is going to create a scatter plot. And then I'm going to define a mapping argument. And that mapping argument is going to tell ggplot how to create that scatter plot. So I'm going to say mapping is equal to AES, which is aesthetics, and I want X to be the age and Y to be the circumference. So if we run this, you'll see that we get a scatter plot of age versus circumference. And so the basic template for ggplots is as follows. ggplot, set the data equal to the data set, plus sign, and typically these are going to be on separate lines. The geom function that you want to use, and so this will depend on the type of plot that you're making, and then the mapping argument. And so that mapping argument is going to be specific to the type of plot you're making. So here we're making a scatter plot, so it makes sense to specify an X and a Y. If we were making a histogram, for example, we would only specify an X. We wouldn't have an X and a Y. And so a little bit more here about the aesthetic mappings. So aesthetic is a visual property of the objects in your plot. They can include things like size, shape, or the color of your points. And so for example, again, we're going to create this scatter plot of the trees. And here outside of the aesthetic, so notice I've closed off aesthetic with the parentheses, I've got comma color. This will make all of the points red. On the other hand, if I moved color into the aesthetic argument, and I set color equal to tree, it will automatically create a color for each of the trees and automatically create a legend. Oh, and that's actually just a doubling of the code. I'm going to delete that one out. That line's the same. We could also do size based on a variable. So now instead of color equals to tree, I'm going to have size equal to tree. So similar to what we had before, but instead of color, it's now done by size. We could also do transparency based on the variable tree. And so transparency is done by alpha. Transparency is really nice if you're going to publish somewhere that's printed in black and white. And then lastly, we could do shape. And so there we have them for the different shapes. Now notice there is a warning here. For an ordinal variable, shape is not advised. But again, we're just doing this for illustration. So this is just a very brief intro to ggplot. Again, we are going to work a lot more with ggplot and different options in the future. So as always, remember that as you work through the material for this course, there is a pretty big learning curve to R. And so your goal is to really just take this one step at a time. Play with these different pieces. One of the best ways to learn in R is to make mistakes, try different things. Again, you can't break anything. So try different, types of code, play around with it, ask lots and lots of questions. We've got, the discussion board, you can ask me questions, but the more that you really engage with it, and again, make mistakes, try different things, that's when you're really going to learn the most. So don't be afraid to do that. And if you don't understand something at first, that's okay too. Again, pretty steep learning curve. And so it really does just take getting in there, trying different things to learn this kind of stuff. And I'm here to help you in any way that I can. So please let me know if you need anything.